So we'll get started with the lab session. Okay, bao soon, Doctor. I'll present my screen. Right. So lab 7, binary search tree, which is only have 3 questions, and I think that we can end pretty early. Right. So I'll start with the first question. So before I start with first question, again, I will start with the explanation a little bit. Okay. So binary search tree, I believe that it is quite self-explainable. So we have binary search and we have the one what we call the normal search and the binary search. So binary search is the one we have learned in our fundamental of programming, which we have an array, right? We have an array of n items. Then usually we search from the left until right. Okay, we search right like this. So the complexity is n. But with binary search, we start from the middle, going down. Then we get the items at the middle, and we find that if it is the things that we want to search for, if no, yeah, we will find either at the left side or at the right side, provided that the array is sorted. So so let's say the item we find is somewhere larger than the current midpoint. We will cut the array into half and search again by looking at the middle of the area that we have cut. Yeah, so we search here and see if it is the item that we want to find. If it's not, we find again, we try to see if it is at the left side or at the right side. Right, so this is what we call as binary search. Yeah, which can reduce a lot of complexity in terms of searching. I am not sure if I tell wrongly. Yeah, but you can search. Maybe if I'm not wrong, it is log n complexity. Yeah, but you can search. I'm bad at counting the complexity. Right. So anyway, now it's binary search tree. So what is tree? Tree is usually something look like this. Yeah. Something like this. Okay. So we have a parent and children, or we call as a root. Okay. We have root as well as leaves. So tree, it grows like this. Right. This is the tree. So our root is at the top and our leaf at the bottom. So the relationship we can define ourselves, and how we want to represent the tree also we can define ourselves. Usually we will do in a linked list approach, but definitely if you set the index correctly, you should be able to achieve the same behavior with array as well. Right. So binary search tree, basically it is a tree, but the special thing is that it is a relatively simple tree. Yeah, we have an item, then whatever at the left side, not whatever, and its children at the left side is less than itself. So it can be 6. It can be 10, for example. At the right side is more than it, right? So, but it doesn't necessarily tells us that the, okay, like this, okay. So if you do the insertion correctly, I think it shouldn't be cases where, yeah, it can be, 9 can be here, I'm not sure. Yeah, maybe, yeah, because it's depending on the children. This one I'm not sure. I think if we drafted the insertion correctly, it shouldn't happen. But we need to verify it, right? So at the right side is larger than itself, and at the left side is less than itself. So basically, this is the only rules, which indicates that our binary search tree, whenever we search at the left side, yeah, it should be less than the things that we are currently at. Yeah, the pointer are currently at. So by using this binary search tree, we can actually do something similar to the binary search. We get the middle point and we find if it is less than or larger than the current value. So we can choose whether to traverse to the left side to find our value or traverse to the right side to find our value, if it exists or not, right? So yeah, that's it. So there are several different approaches that we can use to traverse the tree. So by I mean of traverse is to go through each and every single node. Yeah. Again, using the terms node. Right. So there are several different ways, but the one we are learning is in order, pre-order, as well as the post-order. Right. The most common one is in order traverse, in which the only difference is the timing where we print out the value. So in order is left print right, left print right. Okay. So when we're going down from the root, we don't print it first. We go to the left side first, and until the end. Okay. So we will print out the value because it doesn't have any children already. This one is now and this one is now. So left, mid, right. So this one will be printed out first. 4, then left, mid, right, 6. Yeah, this is impossible to be occur here. So this one, it should be 7. Let's say 7. So left, mid, right, 7, 8, and 10. Right, left, mid, right, then left, mid, right. Okay. So anyway, you just remember that when you are doing the in order search, the result array or the resultant sequence should be in order, yeah, in a non-decreasing order, or yeah, in ascending order, we can say, right? So this is for the in order search, in order traverse, right? So go to a left side until the end, then we use the left, mid, right logic. Okay, left, mid, right, nothing, then this one printed, left, mid, right, okay, printed, then print here and print here, right? So other than this, we have pre-order. Pre-order is you print first. Okay, whatever you do, you print first. Then you go to a left, right. Okay. So when you are at the 8, you print 8 first. Then you go to a left and go to a right. Then left here, you still can go down, right? But at the point you touch that node, you already print it out. Then left, right. So it will be 4, 7, 10. Sorry, a bit messy here. 8, 6, 4, 7, 10. So this is for pre-order. Then how about post-order? P-O-S-T, post-order. So post-order, it is left, right, print. Okay, you go to a left side, then you go to the right side, then only you print the current node. So the resultant array that we can get is 8, you don't print first. This one also you don't print first. And until 4, you'll print it out because left, right, print. Okay, left, right is empty. So it will not do anything. Then here, you will print it out. Then left, right, okay, I think you will print 7 first. Left, right, print. Yeah, because it go to a left side, then it go to a right side. Then here also now, here is now. So 7 will be printed first. Then after this, you will go out, go back to the previous node. You'll print it out. Then go to a right side, print it out because these two are now. Then go back to the root. So it's 4, 7, 6, 10, 8. Right. So I shall never mind, I'll leave it here. Then now we already get 3 different traverse mechanism that we can use: in order, pre-order, and post-order. So what are these behaviors? So for in order, as I mentioned just now, the result of the traverse, it will result in an ascending order array, and or whatever you want to call. Yeah, you will print the in a non-decreasing order. But for pre-order, it seems like there is no particular order. Yeah, at 6, 4, but there's actually a behavior where the root will be printed first because you print first, then only you traverse, right? So whenever you go first, 8 will be printed, then 6 will be printed, 4, 7, 10. So it will print out the parent first, before it print out the children. So this is the behavior for pre-order. So what is the use of pre-order? I've done some searching just now. So for pre-order, usually if you want to print out the hierarchy of our tree, right? So if you want to know who is the parent and what are their children, then we can use this pre-order to achieve that. So it can print out something like a project structure, for example. Yeah, you have some project structure like this. You can print out the parent first, then only you traverse down to the children and go down again to print as a correct order and by hierarchy. So how about post order? It is exact difference from it's a reverse behavior compared to the pre-order. So post order, you will print out the children first, then only you print out the parents, right? It is a bottom up approach. So it will go down to the leaf, then only go back to the root. Yeah. So what is the use? You can find out what is the use. I'm also not sure. Okay, so for pre-order, for pre-order is top-down approach. Then for post-order is a bottom-up approach, right? So although a little bit messy here, so let's go into the questions and see the exact use case. Not the use case. Okay, so here write a program that generate 10 random numbers, then insert into the BST, then print the numbers and display the, okay. Right, so we are going to display in pre-order, in order, and post-order. Then only we find the minimum, maximum value and get the total, as well as to count the number of occurrence. Okay, so yeah, that's it. Right, so we need to define a class called binary search tree. And after this, we insert some random numbers. Yeah, you can use a random to generate the random integers. Yeah, it doesn't matter. Then you construct a tree. After you construct a tree, you do in order, pre-order, and post-order search. Then traverse, not search. Then only you find the minimum, maximum, total, and count. Right, so the code here I modify on top of the codes contributed in the jigs for jigs. So let's see, how can we construct a binary search tree? So inside we have an inner class called node. So the node, initially we only store one node in our binary search tree, which is the root. Then based on this root, we are able to find the children of this root and also to find the children of those children. So what the node need is the current value held by the node itself, as well as the pointer to point towards the left and the right node. So you need the current value and you need the pointer, these are the pointers, to go to the other nodes. Right, so these are actually only objects. Yeah, they are, you can say they are variables. So you need to find some way to link them together, same like the approach we use for the linked list, right? So initially left and right is null. So that's it for the null class, key, left and right. Then whenever we are doing the insertion, I'm going to call a recursive method, insert util. So insert util will help me to traverse to the exact location which I need to insert the current key. So if the root is null, if there's nothing in the tree yet, I will return a new node without doing anything else. So yeah, when I'm insert the util, it will return a new node and assign back to the root, right? Okay. So else, if it's less than our key, then I will traverse to the left side. So if the current key is less than the key, yeah, the current value, let's say it's a 6, we want to put inside. If it's less than 8, then I'll put a 6 at the left side. I'll traverse to the left side and see if this value is less than or more than until the end, right? So I'll go to the left side if it's less than that. Else, if it is equal or more than my key, then I'll go to the right side. Until the end, I'll return the root, right? So Okay. Mm, yeah. So it will traverse until the end where I reach the root is equal to null, this and stopping condition. Then I will put the new node inside there. So now for the in order, also I will have a util. So I use the same approach for all of my methods actually. Have a main method as well as the util method. So the util method will have the information of the root and pass from the root down to do the recursion. Right. So for in order, it is putting the recursive method to the left side first, then print out, then go to right side. Yeah, left print right. So if you want to do like preorder and postorder, they are the same. Just the order of these three lines are different. Yeah. So for preorder, you will put the print first, then left right. For postorder, you will put the left right first, then only print. Right. So in here I only do the in order. Then to find the minimum value that the root is holding at the left side, is the minimum one. And for the maximum, it is the same. Just we go to rightmost. 10 is the maximum. Yeah, so here we have the main method, and we'll call the recursive method util to traverse. Again, traverse. If it's null, I'll straight away return the -1. Else, I'll go to the left side. And after I go to leftmost, I'll return a key. Then here, for counting the in order total, yeah, this one I use a hacky way. Because when we are doing a recursion, we always want to find a way to preserve the value. So that is what I mentioned previously. Yeah, we need to pass by reference in order to preserve the value. So the easiest way is to create an array, because using an array, Java will ensure that every things that call that array will use the exact same copy. So they will not copy their own array and do the operations there. So my result is stored at the first index of array. So I'll pass the array inside the recursive method, and all the value, the result value will be kept in the first index of the array. They will return the value. Right. So in order total is to use the same in order approach to traverse all the nodes. Yeah, because I know that if I want to find the total of the entire tree, I need to traverse every single node. So I can use either in order or pre-order or post-order. It doesn't matter, as long as I traverse all the end nodes in that tree. So use the same way, just that the print I change it to increment to the count to the current array, increment the current value to the array. Then after this, in order count, I use the exact same way. Yeah, because I'm lazy to think of optimization. So now I have I'll do it in order search. If it is equals to key, then it means that that particular item exists in our tree. So, but I don't stop when I found one occurrence. I need to traverse all the node first and to find how many items we have. And then only we return the result. But this one is definitely not going to be an optimized solution, because what you can see here is that maybe you can think of when you're doing the in order search, right? You're already getting an order sequence of items. So let's say maybe your stopping condition might be when the current root key is more than your current value or something like that. So when you are traversing, you find that the current node that you are looking at has the value more than the value that you want to find. It means there's no possibility of the remaining nodes to be at the same value already, because in order is in order. Yeah. So that might be the optimization that you can do. But here I'm not doing that. Right. So let's try to run it and see how. Okay. So you can see here the in order is definitely in order. So we have the multiple occurrence at the same time. Here I set the behavior as if it is equals to the key is equals to the current node value, then I will go to the right side. So probably you'll see something like this. 20 is here. Then you want to insert 20 again, you will go to the right actually. Yeah, it depends on your condition. If it's less than or equals to, then it will go to the left side, else it will go to the right side. And then that's it. So in order find the minimum, you'll go to leftmost, find the maximum, you go to rightmost, and find the total. You will do any kind of traverse logic that you can use to traverse all the nodes. Then you'll print out the total. And to count the number of 20 inside our tree, I'm using the same way as I count the total. Just that I change the condition from simply plus to a ternary operator stating that, oh, if it's equals, then I will plus one, else I will not plus anything. Yeah. So that's it for the first question. It might be a little bit confusing for the structure of the tree, but you can do your testing. Test whatever value that you want to test for. So now we already know that the behavior of tree is like if it's less, then you keep going to the left side. So what will be the complexity of the any kind of traverse? Not traverse, insertion as well as search. So the worst case actually, so when you want to search something, right, it will go down. It's same like binary search actually. So this is the height of your tree. It's 3 layer, right? So height is 3. So when you are searching something, it is possible that okay, it's less than that, it's less than that, then you get a value already. So the number of searches required is equals to the height of your tree. But it is also possible that when you are inserting your binary search tree, at first you get an 8. Okay, then you insert a 7. So 7 is down here. Then you insert 6. Okay, the tree will find that 6 is somewhere here. Then you insert 5. Then you insert 4. Yeah. So this case is actually when you are inserting in a reverse order, then your tree will look like this. Even though there are also five nodes, it will not become the optimal solution, something like this. Yeah, this one is optimal tree. But it is possible that if you are inserting in a reverse order, the height is equals to the number of nodes you have. So in the worst case scenario, still the complexity is equals to ON for searching or insertion. Yeah. If you do insertion, right, you need to traverse until the end. Then only you can insert your new nodes. So it is very depending on your sequence of inserting your tree, the speed of your search as well as the insertion. Okay, so that's in terms of the search and insertion for binary search tree. So for the rest, thank you. 9 be the child of 10. Where is it? Oh, I erased already. Later you see. You try to construct a tree, then you print it out and see. 9 should be, I forgot what I draw just now already, but yeah, it should be. If we have 9, it should be the 12, 10. Yeah. So yeah, I'll pass to other demo.
Okay, share my screen. Okay. So for question 2, you need to create a word frequency generator program. The program will need to read a text file and generate an alphabetical listing of unique words that the file contain and the word count of each word. Okay, so for this question, first you need to read. You need to use the file input stream to read the file first, and then okay, let's us compare to the file. Okay, so in its file, other things that is not string, like the comma and full stop, and then the bracket. And then if you have noticed that it actually only have the small lowercase word inside the result, but inside the text file it provided, it have some capital letter word. So you need to convert all of the word to lowercase, and then you also need to remove this other extra word, extra character that you do not need, like the full stop or comma. Okay. See, inside the file there is same project with you, or you may need to specify its file path. Okay, this is the tree node class of the BSD. So this class, it will store the word and the count, and then also the left child and right child of this tree node. Okay, this is the getter setter of the variable, and then the increase count I use to increase the count of this word. And then the toString, I will concatenate the 0. You need to print, make sure that the count is 4 character. What? So in this toString, I will concatenate the 0 in front of the count by checking its length. And this is the BSD class of our implementation. So first of all, you need to have the root. For this question, actually, the size, min, and mass is not needed, but I just put it here. and then an empty constructor and the constructor that you can create it with the array. Okay, this is my implementation of search, where this question is actually not needed as well. The only method this question is needed will be the insert and then the in order. Okay. So for my insert method, first I insert, I will check whether the root is null. If the root is null, then I will straight insert the word as the root. If it's not null, then I will use a current, a temporary tree node, and then also the last one is a boolean, is same. This one I will check whether if I have, if this word already, if it's not, then we should insert it at the end. For this word frequency generator, actually what you need to know, be careful is that in this while loop, when you're checking, most in other type of, in normal way of BST implementation, if the element you want to insert into the binary search tree is same, then you should return false. And then you not insert the same element into the binary search tree. But for this question, you need to increase the count. So this is a bit different implementation than the normal one. Okay. This current is search and serve as the jumping. Okay? Yeah, the one they loop to the tree, while this temporary is to keep track of the parent, so that we can insert the new word into the right place. So you will need to compare the word. If the word of the current node is larger than new word, then you should jump to the left child of the current, and then you keep track. You keep the parent of where later you need to insert the node. If it is smaller, then you should jump to the right side. And then if it is same, then you can break the while loop and then proceed to this one. So in here, I check that whether if it is same, if it is same, then you should not insert it again. Okay, the insert the same. You need to compare the word between the temporary and then the new word. If is the temporary is left side, you need to put it at the right side. It's guaranteed that here will not have the same node already, because here we detect it. Okay. Okay, okay, and then another method that will be used in this question will be the in order. Okay, so for in order, actually I have two methods. The first one is the method that we can call it outside of this class, and then another one which is the helper method. This one only can be called by this in order, and then be called by in this class. So the be called by outside of a class, we only try to call the helper method, and then we print line. And then for the helper method, I'm using the recursive way of doing this. So at first, I will jump to the left child of the current node. So the first current node will be the root, and then I will jump to the left, and I keep jumping until I reach the end, and then I print this node, and then it will go back. It will go back to the parent node of the most left element inside the tree. Center and right. Okay. So of this is implementation for my binary search tree. Okay. Okay, so for this program, you need to read the file first. Actually, and then you need to create a binary search tree. And then for this question, actually, you do not need to have this while in.hashnet because for this question, actually, this whole file, this whole paragraph is actually only one line. So you can just read one line only, and then for this one, I use the regular expression unneeded character to the to an empty one. And then I changed the whole paragraph to lowercase so that when comparing, it will give the correct result. Actually, it's not correct or not, but if you did not change it to the lowercase, then the uppercase will be lower, consider smaller than the lowercase. Okay. So I split it and then insert it. Actually, here because just now for my implementation, I have the constructor to just insert the words array. So you actually can do it like this. So actually you can do it like this. And then remember to close the input stream and then you print the in order of the binary search string. Okay. Okay. Okay, so at first I print this program, and then the second one I I actually print the line first. Where this is the line that I already replaced all the unneeded character to empty character already. I say in this question you don't need to use the while loop. And then it should print same as the result in the file. Yeah, it's same. Okay. Okay. So what happened if we did not change to lowercase? So for this one, actually you can see that the uppercase word will be in front. And then you proceed with the lowercase after that. And you need to be careful of. Okay, that's it for question 2. Any question 2 you want to ask? If not, I will pass to next demo.
Okay, let's come to question 3. Okay, I will start my share screen now. Question 3 required us to write a program to change a prefix expression and show it out with a binary search tree expression. So basically, it's quite similar with the stack operation where we change the infix to an order that we can do calculation. Where in a stack you put it in a postfix form where you can do a calculation to get the result. So for this question, we are using a binary search tree to put the data, the value inside the data structure, and you can get the result theoretically. So basically, in order to insert the value to the binary search tree, I suggest, I'm not sure whether have a better method or not, but probably we need to convert infix to postfix first. Then we can do we can insert the data to inside the nodes for the binary tree. So the step will be like this. So example for in this question, right? So 4 plus 5 times 7. 4 plus 5 times 7 is the infix, right? Then postfix, when we convert, we get something like this. Where here you times 5 times 7, and then you add the result with a 4. Okay, then after that, from we're using the way that when you do calculation with a postfix, where if you see a number you'll push it inside a stack. You see the operation, then you will proceed the operation. So in this case, so when we look at the first input is a number, right? So stack will push 4 inside it, and then 5, and 7, and then times. Since this is the operator, so we'll pop 2 of these, bind them together. So in this step, different with the POSIX calculation that you do in a stack. So we will pop these 2 values, and then we will build a knot. A knot with left side is, so you will have a knot with a value of times. Then below it, left side will be the 5, and the right side will be a 7. And then you continue to read the next input, which is plus, right? And this is the operator. So we do operation. We pop 2 of these. Which the first one is a knot that we formed before, which is this one. This one, and then we build a new knot that link them together. If this one will be in the, this one will be at the left side, and then this knot will be the right side of the a knot. So this is the root knot of the of our binary search tree. In this tree, right, when you do when you want to compute the calculation, so basically you either compute from a, you can compute from a left side. So in this case, we'll do a recursion where we found the bottom of the left side, which have not any value. Since 5 is the last knot where you don't have any left knot and the right knot. And then you do a computation with and then you continue to the right side. 7 also, you don't have any value at the bottom. So then you start to do a computation, compute, where you taking these 2 values, the left side and the right side, and then you compute with this one, which is multiply. So in this case here will become in this case, after finish computation, here will become 35. And then you go back to here, since you already finished the left side, so you continue the right side, same progress. You will check for every knot, and since for this one, number 4, you don't have any left knot and the right knot, so you proceed the calculation part. So here you will plus them, then here you will get 39. And in this we do the compute function. You only insert the value inside the initial tree, and then we print it out order and a post order. Okay, first you build your own nodes that holding the value, the generic value, and then the nodes have a toString method. For this one, you can either put it in a class called binary tree, but I didn't do a class called binary tree. I just take the node the root node as the binary tree. So I put my toString function inside the node class, where I have 3 toString function with in order, preorder, and postorder. Okay, this one will be a recursive method where you start to print everything from a left side with you by calling the same method name, and then you print the value of itself, and then you print the right side. Same as preorder and postorder, just in different order, where in preorder you will print out the data first, and then you print the left side, right side. And then postorder you print out left side, right side first, and then you print the value of the value itself. Okay, let's see the class inside the binary tree expression. So in this class, I take some of the function from the lab 5 question 2 and I modify it. So basically, for this function is the method that convert infix to postfix function. So in case you forgot the algorithm how it works, you can go back and look for the lab 5 question 2. See how you convert the infix to postfix. And then this bottom also have 2 function where take it from lab 5 question 2, where I check for the purity for the operate, where because of multiply and divide and also modulus will have higher purity compared to plus and minus. So you will check the purity, whether you should put it in front or behind. Okay, next for this function is the function where you convert the postfix, put it inside the binary tree, where I'll build a stack with nodes. The stack were holding nodes, where the nodes were holding a string f as a value. So basically, now I do another example for, let's say our input is 3 minus, let's say our input is 9 minus 3 times 2. So in this case, you will look through every character of the postfix string, and then for each character you check whether it is an operate or is an operator. So it is an operate, so it's a number. So you will push it with a new node without any left node or a right node. So it will become the left of the binary tree. Else if you found it is the operator. So here I do a checking, because as you are doing an operation, you must have 2 value. So in the stack, you must have 2 value and above. So if you have a stack which is less than 2 values, so can we say this postfix string have some error, so it's not a valid postfix. Else you will pop two not from a stack, and then you build a new node with two value from the stack, where this from you will insert to a left side and the right side of the node. So this order is not very important. You can put either this the left side, this the right side, or this the right side and this the left side. Just it will affect the value that you will print out later, but it will not affect the function that it have, which is you can compute to a correct value if you implement correctly. So you build a new node with the operator with two nodes that consists maybe a number or another operator that will compute another two number. So in this case, the loop through, right? So your stack will have first a value of 9, and then 3. Oh, sorry, this is a infix string. So in postfix, we will have something like this. Then the stack will push a new node with a value of 9, a new node with a value of 3, a new node with a value of 2. And then the next part, so you find a operator, so you pop these two out, maybe a new node with left side, right side, and also itself. Then the last step, you will pop these two out. So in the end of the process, your stack will consist only one value, and we only have one node. So you just pop up the node. The node will become the root node that we have. It become the root node that we have. So last step, we try to check our class that we built, whether it is function correctly or not. So we will build a new object with a infix of this one. So I take from a question with this one. So then for the second algorithm, second algorithm may have errors since I didn't implement a bracket the checking. Okay, this for the first one, where when you input the value inside the constructor, so the constructor, what it will do is it will convert the infix operation to the postfix, and then from a postfix it will put it inside the tree, and this is the in order, pre-order, and the post order. I'm not sure why the pre-order and the post order is another way around. I'm not sure whether now based on I search from internet, I don't think I implement wrong for these two method, for the pre-order and post order. So maybe you can confirm with your lecturer about the answer for these two, whether it has been another way around or this one is the correct one. Okay, then for the second one, since just now I say I didn't implement for the bracket one, this means I didn't do checking for this one. So it might have a error for getting the value. No. Oh, I just do the bracket checking before, since I take the algorithm from a lab 5 question 2 to modify it, and we already do some checking. It's just different is from lab 5 question 2, I have do a space in between every value. For this case, I didn't do a space, so everything that have a space I will delete it. So for this one, if you convert into a postfix, you will get a value like this. When you print it out, in order you will get a 5 times 4 plus 8 divide 2 plus 7, which is same. In this one, you can realize that if you print in order, you will get back the order which is same with your expression, where 5 times 4 plus 8 divide 7 plus 2. If you get a prefix, so you will get a prefix. If you print with pre-order, so you will get a prefix. So the prefix will be in this case the prefix will be plus divide plus multiply 5 4 8 7 2. And as for this one, if you printing a post order, you will get a postfix. 5, 4 times x 7, 8, 8 plus 7 divide 2 plus. Okay, I have any question regarding for this question 3? Really, since the time is quite early, we can try to do the compute function where we compute the value inside the binary tree and we get the output of this expression. So okay, so for the compute function, so remember we say just now we will start to compute everything from the left side. So if you found any nodes from left side, so you will compute, or anything from the right side, you will compute also until you didn't find any value, and then you start to do the operation. Let's say we will do a checking where if left node is not equal to null, so we will do a computation for any for getting a value from for the left side, and then same for right side. So if it's not equal to null, so we will do a computation. We will compute for the value from the right side. Okay, so for this one, about for the on value, so if you found that the node itself is holding a branch, it is holding a number, so you will just return the number. Else you will do you will compute any value from left side and the right side, and then you return the value. In this case, okay, I'm gonna reuse my code from the left 5. Okay, so here come we can check whether it is appropriate or not. Okay, for this one will be 5 times 7, 35, and then you plus 4, you will get 39. Okay, correct. And then for this one, you will get 28. Here will be a 28, and they will divide. You will get a 4. 4 plus 2, you will get a 6. Okay, so this one is working properly. So basically, from learning this one, you can know that for compute the expression, either other than stack, you can using binary to work it out. Any question regarding this question?
Okay, since it's still early, so we can chit chat a little bit. Instead of starting the next lab, yeah. So how to say? Because currently we are doing e-learning, so the way you are learning might be different than we are previously during physical classes, right? So you might not have the motivation to do the tutorials or labs yourself. Maybe some of the time you might discuss with other people or something like that. So the outcome that you can get from learning here is it might be less compared to physical classes, and the way examinations are conducted also will be different because you are able to search Google now. So now you need to think instead of thinking instead of learning the how to implement something. Yeah, you need to know how to tweak the data structure to do something that you want them to do. Okay, so data structure is like just now we discussed mostly about the binary search tree, but we didn't combine it to the previous things that we have learned, right? So let's say if we want to use a binary search tree, but inside the node, actually we can implement it as any kind of node. Yeah, it is very useful when we think of that way. So for example, if the binary search tree, we want to put some students inside. So we just define a student class and we implement a comparable and implement that abstract method, compare to method to define our own comparison algorithm. Then it will behave as what we want them to. So maybe there are some situations where the questions is very tricky. They want you to use your own the own customized custom classes in using some primitive type teacher. So you need to know how to take with your solution to cope with that yeah. So to cope with that situation. Mm. So that is one thing. Then I always think that the importance of learning programming is to know the concept. So even if in actual situation you won't know how to code some trees from scratch or something like that, but at least you know what it does. Okay, at least you know the concept. That the underneath implementation is the lowest level of details which you need to know. But even if you know, there are many sources able to help you to implement the inner part, the core logic for the tree, for example, or linked list. So as long as you get those concept right, then you are able to find a solid implementation of a data structure, be able to solve any problems, most problems. Okay, so what I want is that you can, because it is a physical class, I will tell you that to memorize. At least for examinations, you need to memorize algorithms for you to construct, like how to construct a link, how to construct arrays for yourself. But because it's conducted online, so I will tell you to emphasize more towards the higher level of abstraction. So abstraction means that instead of focusing on how to you focus on how to implement the implementation, no, how to use that concept to conceptualize your data and it with your problems. Okay, so for example, give you a problem and then you need to derive what kind of algorithms, what kind of data is suitable to use that are the higher level of thinking. Okay, so you don't worry about the details, you worry about the concepts. Okay, that is for the academics one. So I believe because of this, we have many more assignments than in the previous year. So the same, even us as a final year student also we are facing a situation where that subject only has one assignment, but now then previously two, there are three. Yeah, something like that. Previously the examination is examination. Now the examination is assessment or some random 15 minutes quick quiz. So there are many possibilities of how it's going to be, especially when we are approaching the end, right? So I think because we have so many things to do, so instead of stressing yourself, it's time for you to make decisions. Okay, maybe some assignments you don't have to be so OCD or so perfectionist until you want to make everything perfect. Instead, focus on completion first. Okay, because we don't have much time, and work-life balance is very important. That if you need to include your time for yourself instead of purely working. Okay, so there should be within your plan also. Like after 10 p.m. you don't want to do anything already, then just don't do anything. Leave your teammates to suffer. No, so yeah, when you are planning your daily schedule, just ensure that you complete your assignment first. Don't stress yourself to make it perfect or to make it as good as possible, but make it as complete as possible first. Okay, so there's one thing regarding how you plan your schedule. If you are thinking that you are too busy, then I can tell you that I might be much more busy than you because I'm taking some external software projects other than final year project and also assignments, exams. Yeah, so you should be able to do just ensure that you take care of your mental health also. Yeah, rather than just chasing all the way to the to your academics career in academics, but need to find some channel to release your stress. To yeah, it can be in any form as long as you're at home. Yeah, so yeah, that's for your yeah, the things I can tell you lah. So if yeah, because I've told you that I am currently taking several software projects. Yeah, that is under, I think it's under research, under the university research project. So there will be grant for those projects. And as first year, I think it is important to expose to you first regarding these things. Okay, as a student, actually we have many opportunities available. So if you want to grab that opportunities to earn some extra income or to learn extra things, you need to be wise, or how to say, be more, have an aim, okay, have an aim that can help you to grab those opportunities. So everyone have the similar amount of time. Then during the extra time, you need to decide what things to learn if you want to. Yeah, don't simply learn for academics only. So for example, currently, okay, if before internship I wasn't actually able to commit to any project in any form. But after that, after the internship, I suddenly know that, oh, actually I don't have to be really good to contribute. But I still need to have some fundamental of knowledge regarding the current languages, programming languages to be used in typical software projects, or yeah. So for example, one of the projects I'm doing is I'm working on the backend side. Backend means because now a very popular approach for a software project is to communicate via REST API, REST API. So maybe I can share my screen. Yeah, I love to use either notepad or pen. Right, so current communication for software projects, usually we will use the REST API. It is a very simple concept actually. You can search for it. What is REST API? It simply said it is something like the usual thing we are doing on web. So we send some GET request, then we fetch the response from server, and we do either display or return the results to the clients. So we have a very obvious architecture that definitely we will have a front-end team in charge of displaying and sending requests. And we have a back-end team in charge of computations of the data and return the corresponding results. So these are the two common approach that you can think when you are learning. Either you want to go to the dashboard, not dashboard, sorry, to use to the the term used already. Yeah, either you can start finding some sources to help you to learn in front end, or you can start finding some sources to help you to learn in back end. Like me, I actually my field is in back end, is more in back end, and I can tell that in actual software project, even when I was working in Grab, there are many services in Grab, so I cannot tell the complexity just by joining a single service. But the business logic, or most of the logics that in that service is actually pretty simple. So we don't need to use even any kind of data structure. Just that there are two quite important concepts that we need to know when we are working as a developer. Yeah. The first thing is the optimization of our database schema. So as a backend member, you need to know how to define your schema, and mostly, not mostly, but at least for my side projects that I'm doing, because I am the guy, so I decide what tools I want to use. Then of them I use a MongoDB to a NoSQL database to manage my database. So that will be my selection. Then there will be the mandatory requirement for anyone to onboard in that team. Yeah, but it's actually not that difficult. It's just a JSON documents that handle the request. No, they handle the data. Okay, so yeah, what about MongoDB? I want to say already. Okay. Anyway, okay. Yeah, this is the most important thing. Yeah, you need to optimize how you organize the data. Okay, how you organize the data. We are not using for data structure wise. Yes, we have classes, but the classes are mostly. It is possible we will make it not nested so much. Yeah, to reduce the complexity. When we are working in a in a team to minimize the complexity instead of doing something fancy. Yeah, as simple as possible is okay, as long as it can solve the problems and it is manageable. So this is the first thing. The second, concurrency. So because concurrency is an issue that we need to take care of, which might be currently I didn't handle it yet in the current projects because I don't have time to debug. But for the concurrency, it is to increase our efficiency in codes. So for example, when you are doing operations on air, actually you can let's say if you are doing a for loop, actually for loop you can break down into several different processes, then let them do their own part, and then only we merge the result together. It will make our process much faster if we are doing it properly. So that's for the back end side. So what is it for the front end side? For front end side, actually we will need some knowledge definitely in JavaScript. JavaScript is the hardest language I've encountered. It's not difficult actually, but I don't like the way it conduct the it operates. It's just a personal preference, but JavaScript is an asynchronous language, which is very much different to Java, which is in sequence. Everything you run at the top, it will run first, then only it will go down to the bottom. But JavaScript, it is asynchronous. The process at the top might not be finished before it comes to the next line. And now the funny situation is that Java is getting more asynchronous. It's like they are starting to expose some mechanisms, or it already has the mechanism for us to do asynchronous programming. And JavaScript, it also has some ways for us to do something like Java. So they are kind of initially they are quite different, but now they can be met very, very similar also. Anyway, for this side, I would suggest you to start learning. If you want to go to the front end approach, you can try to learn some HTML stuff, HTML, CSS, JavaScript. Try to learn how to import an API and library, how to integrate with an API. Then that will already help you to onboard anytime in the future for your front end career. If you want to go to a back end, you need to get used to using Java and know how to use Java. It's not necessarily Java. I don't use Java actually. I use another language called Golang. But anyway, any kind of back-end language you can use actually use for creating a REST API, and at least you need to know how to create a REST API and how to process and return the corresponding results, and how to interact with the database. Then you are good to onboard to the backend already. It is not difficult actually. Another thing is the mobile side. So another project I'm taking is a mobile application that is by React Native. So React Native is a hybrid language that once we develop it, it can be used in both Android and iOS, which is convenient, but also inconvenient because it is JavaScript. Yeah. So it is a fun language, I can say. And I thought that those hybrid languages will have a poor performance, but actually they are bullshit. So the performance, even in my phone, is pretty fast. Yeah, it doesn't, you cannot feel any difference to some native Java, Android application or iOS application. Yeah, so anyway, you still need to learn JavaScript and CSS. Yeah, they're the same concept actually. So for mobile, it's more difficult because the complexity of devices. We have so many devices, so many models, and every model will have their own behaviors. So if you want to go to a mobile approach, I think the prerequisite will be to handle the front end properly first. Front end is usually, it can be mobile or website, but I suggest to learn web first before you come into the mobile. So if you want to know the pathway for learning or pathway for you to to join any software projects, actually you can contact me. Then although currently for the projects I'm taking, I am not recruiting anyone yet because I don't have enough workload to recruit people. Yeah, like you if you join my team, then probably you will not have any task to do. So I don't want to have that situation where some people joining in then don't have nothing to do. That's my style. So, but if you want to know what things to learn in order for you to join projects, then I have some channels for you, some guideline for you lah. Not channels. Due to availability, I also can't guide you one by one. But guideline I can give you. Yeah. So the many things you can learn other than coding if you join projects, especially projects where seniors are involved. So they might have something related to management as well for you to learn. And for information, we don't actually code. In a team, we don't actually like always only code. Yeah, we also have to handle some user side issue, and it is interesting to learn how to deal with the users or how to communicate with your clients. Yeah, those are things that those are the real things. So you can say it is there's always a trade-off because we have equal amount of time. If you join projects, it might affect your academics achievements. So, but I still think it is worth it to try and join and commit as much as you can. Yeah, it's not to be able to join a project is how to say, to be able to join a project is only the starting point, but what you have done in that project is the goal that you want to achieve. Yeah, it's not only joining. If only joining, I can say that I also have similar experience where I joined a project and I did nothing, then I get kicked out. So there's still I didn't learn anything out of that project because I didn't contribute anything. So the amount of contribution will reflect in your whole career. Okay, it's something related to your future instead of purely academics. Yeah. So be more thoughtful when you're thinking about the way that you want to go. Yeah. Is it you want to focus on academics and be and continue with master and continue with PhD and finally becomes a lecturer? That will be another career. Yeah, that one you definitely have to focus on your academics and get some good grades and to secure your placement in your postgraduate journey. But if you want to be a developer, if you want to be involved in the software company or organizations in any form, like a product manager, a tester, a developer, the kind of things you cannot learn. The resources we have in these courses are limited. So we can only teach you the concept, the theory, like you learn IS, but you didn't actually apply it anywhere. In the assignment, I believe that most of the time we are just bluffing the theories. Yeah, we find some random sources telling, oh, this information system is like this. Then, but in actual situation, we did nothing to accommodate or to implement or practice that particular information system. That will be a great loss, I can say, if we are only focusing on academics, and also we want to not go to the academics career in the future. Yeah, so these are things that maybe you need to consider. But since you currently is online learning, so you have more time to think about yourself and your career. It might be too early, but it's never too early, I think. Anyway, any problems you can find me. Then probably I can give you some sources of where I learned those things and how to get started with development. These are things I can kind of provide you other than the academic studies. So as you can see, I'm not a very technical in terms of the knowledge. Yeah. So for example, like tree, I don't actually know how to implement in real life. So, but at least I know what I can do. So I can solely contribute of what I can do to the team. And I think that is the most important thing. You don't learn until level 100 and know where to apply your knowledge, right? So practical stuff is important. I think I talked very long time. Law. Anything other demo want to add on, or not add on, want to cut me off also can. Else I will just keep talking. So yeah, I think there'll be I think that will be the end of our class today. So I don't think I contribute much in my FYP team. My teammates suffer actually because as I mentioned, there will always be trade-off. So I don't think at last my FYP will be very fancy because of the time I have to spend with other things. And I don't want to keep working without playing games. So I also need to allocate some time for game. So FYP wise, I'll try my best, but probably not going to be very fancy. Yeah, so I think I'm sorry, Doctor, I'm Jia Xiong. Yeah, I'm sorry that I'm using my personal account, so my name it doesn't show who am I. Yeah, I'm Jia Xiong actually. So yeah, if you have any problems, then feel free to come and find us. If you are interested in software projects, although I mentioned that currently I'm not recruiting anyone, but one of the projects is still lack of people actually, especially in mobile development, the React Native part. But because I didn't get any grant yet, so I don't dare to accept people. But maybe in the future, if we get a grant, then I'll start to recruit people. Then if you're interested, then you can find me, then we can discuss together. Right, if you have any problems, then you still can ask until 12 p.m. I will pass back to Doctor. Thank you. You can try to be involved in mobile application development. Actually, it is very new experience to me as well. Previously, I don't know anything about mobile development, but after joining the project, then I start to think that it is interesting, but it's difficult. So in mobile, there are many kind of conditions that we need to handle, like the situation where the user click elsewhere, like click the back button, then what should we behave, and when the app is running in the background, how should we code them to behave. Those things need some experience as well. So we are still in the learning process where there are many conditions we haven't able to handle properly. So if you have prior experience, then definitely we will hope that you can come and help out the project. Both projects are to cater with the to help the community to solve the problems regarding COVID-19 actually. Yeah. So currently, most of the opportunities currently is although it's not very good, but actually the opportunity is in the situation currently, which is COVID-19. That's our major concern. Like one application is for helping the patients to do some monitorings. Another one is for them to do contact tracing. Yeah, not sure if applicable, but hopefully, because there are several things that we as a developer we cannot solve, like the legal issue, like the privacy issue. So those things are the user side issue, which is also interesting if you are joining the software project. That are also some uncertainties that even if you have some brilliant ideas or if you have the skills to develop something, it might end up that your project might fail because of these security concerns or government policies. So joining this project also will help us to grow our knowledge in terms of how to deal with those issues, the legal issues, which usually, or I can say 100% of the time, we are not dealing with it, because like when we are doing our assignment also, we don't actually care about the copyright issue or plagiarism. Just reference whatever we want to and not referencing other the sources. So those are the usual way we are doing things. But those are for assignments, not the actual situation. Yeah. So another interesting stuff to learn. Yeah. Until 12 p.m. Anyone also can, right? Previously, I thought I have to go for, oh shit. Yeah, I think I need to go for now because there's a demonstrations that need my feedback. So I will have to join that meeting. I'll pass to other demos as well as our doctor. Thank you so much.
So any question regarding for anything that you want to ask us, you can reach us anytime you want. All right.